guest today is a world-renowned medical doctor and one of the world's leading experts in infectious diseases, immunology, and virology. He labored away in the research trenches for 26 years to co-invent the rotavirus vaccine, which to date has saved millions of lives. He's served on the CDC's Advisory Committee on Immunization Practices and is the director of the Vaccine Education Center at the Children's Hospital of Philadelphia, as well as a professor of pediatrics at the University of Pennsylvania. But when he's not saving lives, he's educating the public and has appeared everywhere from The Daily Show to The Colbert Report, from NBC to CBS, as well as in documentaries by Nova, CNN, and Frontline, where he's battled against harmful pseudoscience and misinformation, going up against ignorant celebrity titans like Gwyneth Paltrow and anti-vaxxers like Jenny McCarthy and Chuck Norris. But he's also a firm advocate for proper vaccine testing and safety, and is not afraid to call out outdated medical practices long considered gospel, as shown in his most recent book, Overkill: When Modern Medicine Goes Too Far. He's published 9 books and over 160 papers in medical and scientific journals. And as the world races to find a cure to the current coronavirus pandemic, he sits on the FDA's Vaccine Advisory Committee to help ensure that we get this right. He's a doctor and a teacher, fighting tirelessly on our behalves. Without any further ado, I give you Dr. Paul Offit. So how are you doing with this whole shelter in place quarantine thing going on right now?
Well, we're all hanging in there. I've been doing a lot of writing, so that's good, and doing a lot of interviews, so that's good, because you can do those things all by yourself in a room, so it hasn't been too terrible. Absolutely.
Got to get good information out there to battle a lot of the pseudoscience, which is one of the things I want to talk about today. But first, I wanted to cover some of the statistics with the coronavirus. Right now, the total worldwide deaths have just broke 50,000. U.S. total deaths were over 5,000 as of yesterday, or as of today, actually. The total cases worldwide is approaching 1 million. And total U.S. cases is at 226,000, with 1,049 new deaths just yesterday. So those are some pretty alarming numbers. Hopefully we can offer a little bit of hope here for a cure, for a treatment, for a vaccine. But I wanted to start with a little bit about your journey. You were one of the co-inventors of the rotavirus vaccine. That was about, what, 14 years ago that was 2006?
Exactly. It was licensed by the Food and Drug Administration and recommended for universal use of all children in the U.S. in 2006.
And in that time, it has saved countless lives. If I'm not mistaken, millions of lives. There were 1,000 plus deaths a day from rotavirus.
That's right. About 2,000 deaths a day in the world from that virus. That's right.
Wow. Okay. How did you get into that? I remember reading in one of your books, you had a story of a girl that came into your hospital with the rotavirus. Do you want to tell that story real quick?
Sure. This was, I was at Children's Hospital in Pittsburgh. I was an intern. There was a mother of a 9-month-old little girl who was great. I mean, she was a really good birth mom. The child had fever and vomiting initially. She called the doctor that night. The doctor said, give frequent sips of fluid containing sugar or frequent sips of fluid containing minerals like salt, which she tried to do. The problem was the child was vomiting and wasn't holding anything down. By the next day, the child was severely dehydrated. She brings her to our hospital. We whisk her back into the treatment room and try and put in an intravenous line to give her the fluid she's lost to restore her blood pressure, which was falling. But we couldn't get in an intravenous line because she was so clamped down because she was so dehydrated. So we called a surgeon to come down to put actually a catheter into her neck, into her external jugular vein in her neck. But her blood pressure fell out. So we took a large bore needle, the kind of needles that you use to do bone marrow biopsies. We put it into the middle of her bone, just below her knee, to try and instill fluid that way, and she had an arrest. And we were unable to resuscitate her. So she was a perfectly healthy child 2 days earlier, and she came into our hospital dead from this virus. And then comes the worst part of all of this as a physician is the mother was waiting outside to see how things were going. And, you have to go out there, sit down in the waiting room and explain to her that her perfectly well 9-month-old child has died from this virus. It's just the worst thing in the world. And it's the kind of thing that sticks with you throughout the attempts to make this vaccine. That story is always in your head.
Yeah. Wow. So when you were making that happened before you started working on the rotavirus or during?
No, that's right. I was just an intern at Children's Hospital in Pittsburgh. I started working on the vaccine a few years later in 1980. This was actually like in 1977.
Yeah, that's incredible. So now as this whole pandemic is going on, obviously these types of cases are starting to overwhelm hospitals, and you have people who are doctors who are in the same situation as you and family members who are in the same situation as this little girl's mother. So the race to find a cure or a vaccine or just some kind of treatment is more urgent than ever. What are the different possible ways? I wanted to kind of talk about the difference between antigen treatments, various kinds of cures, the progress level of them, vaccines. What have you seen so far that you find the most promising for pushing back against the coronavirus?
Well, certainly the thing that would be most easily or most readily available now would be an antiviral medicine. So not a preventive like a vaccine, but a treatment. And people are now looking to see whether any of them work. The one that's gotten probably the most press because Donald Trump sort of promoted it was hydroxychloroquine plus or minus azithromycin. One is an anti-malarial drug, the other is an antibacterial drug. We'll see. Hopefully there will be studies done in children, in adults who either do or don't get that drug, so you can see whether or not it works. And there are specific antiviral drugs that have names like remdesivir or flavipiravir, which we can again test to see whether or not they work.
Okay. What about, I saw something about antigen treatment, and I know that back when I think it was smallpox reemerged, that when smallpox reemerged, I think it was in like 2009, it kind of reared its head quickly, and there were people who still had antigens in their blood from the previous smallpox epidemic or pandemic.
I think what you might mean is convalescent sera. So in other words, that you have in this case a COVID-19 infection. Your body responds to that by making antibodies that then are in your circulation. You can then take that so-called convalescent antisera and then give it to people as a way to fight that virus infection, which is really what the vaccine does. The vaccine basically causes you to make your own antibodies. Here, what you're doing is giving a patient somebody else's antibodies to try and fight the infection. And that was done. That's been done, for example, for diphtheria, we use antisera. For tetanus, we use antisera. For polio, in the old days, we used to use antisera. So I think that's where that comes from.
Okay. Now, you had mentioned hydroxychloroquine. Now, I know that a lot of people have a ton of misinformation going around related to that. There have been people who have been, having a run on that particular drug, hoping that, if they get coronavirus, that they can take it and be protected against it. Some of that I would like to kind of dispel. First off, what if, so I heard that it can potentially be fatal if you have heart conditions or potentially cause long-term blindness. Now, as a doctor, you take those things into account. What are the warnings and the cautions that you would give to people who would just take self-medication into their own hands?
Well, again, I think people have the false notion that if somebody is sick, that you can't hurt them. That's not true. You can hurt them. And if someone is sick, either one of three things can happen. They can get better, they can stay the same, or they can do worse. You want to make sure you don't take somebody who is going to stay the same or do better and make them worse. And that's why you do these studies, to make sure that you, and hopefully the drug works, but at the very least, it doesn't hurt you. So I would wait. And even some doctors are currently giving this drug without clearly knowing that it works and without clearly knowing that it doesn't make you worse. And I just really wish people would wait till the studies are there before they do that. And that's what happens. I mean, people are panicked. People are really scared about this virus. And when people panic, sometimes they do things that are ill-considered.
Yeah, there was an old man, a 60-year-old man on March 23rd who he consumed fish tank cleaner because it had chloroquine phosphate, which is a different chemical molecule, but he thought it would protect him against coronavirus, and it wound up killing him. So that's kind of the danger of not listening to and heeding medical advice with this type of thing. Now, is that's an anti-malarial drug, isn't it?
That's right.
So I travel a fair amount, and my doctor prescribed me some malaria medication a while back, but this is Atavaquan I'm probably butchering the name. You've probably heard of it, Proguanil or something. And
that's right. That's not the same thing, but that's another anti-malarial
So
drug.
just because you take an anti-malarial drug that's a different drug, it won't necessarily have the same effects as hydroxychloroquine. Is that correct?
Assuming trihydroxychloroquine actually has any effect that's good. So we don't know that yet.
Okay, good to know. In developing a vaccine, so you worked for 26 years on the rotavirus vaccine. What are the different types? I know there's at least 4 different kinds of vaccines. Which ones, like what are those different options, and which ones do you think hold the most promise for the coronavirus?
Okay, so I'll start from the beginning. I think that the best news about the possibility that you can make a vaccine is that natural infection induces protection against disease associated with reinfection. So we don't know that yet for this virus, but we do have information with human coronaviruses. I mean, there are 4 different types of human coronaviruses that circulate in the United States every year and probably account for 15 to 20% of the respiratory diseases that we see come into our hospital every year. So then the question is, if you're infected with one type of human coronavirus, can you be protected against moderate to severe disease associated with that same type? And the answer is yes. That study's been done, so that's good. That's number one. Number two is you really know what part of the virus you're going after. It's that protein on the surface, that so-called spike protein that allows the virus to attach to cells. If you can make an antibody response to that spike protein, then that's going to prevent the virus from attaching to cells and infecting cells. That's good. Plus, you know that we can make, in some ways, a purified protein vaccine using a surface protein. That's what the hepatitis B vaccine is. That's what the human papillomavirus vaccine is. That's all good. So there are several ways now that you can cause people to get an immune response to that protein. You can just give the protein, as we do with hepatitis B vaccine or HP, human papillomavirus vaccine. You can give messenger RNA, which is sort of has the code for how to make that protein. So when you inject someone with messenger RNA, and that's the study that's currently going on in Washington State in people, that messenger RNA is translated to the protein, and then you make an antibody response to the protein. You can do the same thing with DNA, which is sort of a step away. You inject people with DNA that is that DNA for that protein. The DNA is converted to messenger RNA, which is converted to the protein. Or you can have a virus that's sort of a harmless virus, into which you have now cloned the gene that codes for that surface protein. So all those things are being done right now. Clearly, the leader of the pack right now is Moderna's messenger RNA vaccine, which has now been put into about 45 people, adults, 18 to 55 years old in Washington State.
So they don't even have to, like in the past with inoculations, they would have like the cowpox, strain of the cowpox virus, because you're less likely to die from that. And then they found that would help protect against like smallpox. If I'm not mistaken with my history of vaccines, obviously I'm not an expert on this topic, but nowadays they don't even have to infect you with anything like a whole virus. They can take like just a strand of the RNA, if I'm hearing you correctly.
No, that's exactly right. I mean, we live fortunately in an era of recombinant DNA technology and with advances in protein chemistry and protein purification. So you no longer have to give a whole live virus. You can actually just give a purified protein, assuming that works. And I think there's every reason to believe that approach would work.
Okay. What are the safety concerns, though? Because I know that in the past there have been some dangerous past vaccines and some issues that you've brought up. What are the safety concerns right now with this current virus or with this current vaccine?
Well, so there's some theoretical concerns. I think Peter Hotez at Baylor has raised the theoretical concern of something called antibody-dependent enhancement, which is what happened with the dengue vaccine. So dengue is a virus that infects about 390 million people in the world every year. It kills about 20,000. There is a dengue vaccine that was developed a couple of years ago. What they found was that when they gave that vaccine to children who didn't have antibodies against dengue, had never seen natural dengue before, that when they then, after the vaccine, were exposed to the natural virus, were infected with the natural virus, they did worse than children who actually had never gotten a vaccine. The vaccine made you worse because it's a sort of a technical reason, but the antibodies that you developed against that vaccine actually helped the virus get into cells, so it made you worse. So you always have that theoretical concern. But again, that's why you do pre-licensure studies. And hopefully those pre-licensure studies will be big enough to ameliorate that safety concern. Okay,
so if right now they're saying that there's potentially going to be a vaccine going to market in the next 12 to 18 months, does that seem like we can do that kind of testing realistically in that time frame to roll out the kind of clinical trials to make sure that it's safe?
Here's what maybe I'm a bad sport since it took us 26 years to make our vaccine, but I would say this. Here's what you need to do. Right now, they're just doing dose ranging studies. I mean, they don't know the dose. So, and you only have 15 people per group. You start with a low dose, you go to a middle dose, then you go to a higher dose. Let's assume one of those doses induces an immune response. Let's assume that's true. Then what you should do is you should do really thousands of patients at that dose to make sure that it consistently induces what you think is a protective response, and it consistently is safe. Thousands of people. Then now that you're at a break point, you really don't know whether the immune response that you've induced is protective. You don't know that. So you have one of two choices. You can either do a trial, meaning an efficacy trial, because you don't know the correlate. You don't know the immunological correlate. Or you can hope that you're right. So I would like to think that we would do an efficacy trial. And probably the group to do an efficacy trial in would be healthcare workers. I mean, those are the people who are most likely to be exposed to this virus. So you would give healthcare workers, you would give some healthcare workers the vaccine and others not. That all takes really a couple years to do. Typically, I certainly, as we did it, you sort of work up, you work your way up, to sort of larger and larger trials, because you're always testing the water with one foot to make sure that things are safe. You don't test it with both feet, and so you see. Then what you need to do is you need to make it. That's not a trivial issue. I mean, although the good news about messenger RNA is you really can scale up to millions of doses quickly, it still has to be encased in a fairly complex lipid delivery system, which hasn't been scaled up yet. And I can't imagine would take less than a year to scale up and package. So I just think the fastest this could be, it seems to me, would be several years. And also, I think you would have to bypass the Food and Drug Administration really to do this. And I'm on, as you mentioned, the FDA's Vaccine Advisory Committee. So typically, we're the ones who evaluate whether or not something it looks to be safe and effective. We did that, I've done that with a variety of vaccines. I just imagine you would have to go to bypass the FDA, and that's something. I just think it's that we have a break the glass mentality. That right now this virus is causing, it's caused 50,000 people to die in this world. It's caused, upwards of 5,000 people or more to die in this country. And if the predictions are right, that this is going to kill 100,000 to 240,000 people in this country, that is not trivial. So you want to really get this out there as fast as you can. But on the other hand, you do have to balance that with safety issues. Because first of all, those numbers may not be right. It may be less than that. And it may, for all we know, not even come back next year. I mean, SARS didn't come back the following year. MERS didn't come back the following year. This may also not come back the following year. You don't know that. So it's that balance. And I guess we'll see how it plays out. I think Dr. Fauci wants to do the right thing and wants to do it in the safest, best way possible. But you really want to make sure before you give it to millions of people that you've done your due diligence to make sure that it's safe and that it's effective.
You were saying it might not come back next year. I was reading something that was saying that in tropical climates, it still seems to be spreading at an alarming rate. Do you think that as the warmer months hit, that will affect the spread of this virus? Or
that was always the hope. I mean, because that's true of human coronaviruses. I mean, they tend to be winter-spring viruses. The reason being that as things get more hot and more humid, that those droplets that you then put out by sneezing or coughing or talking tend to accrete water more and drop more quickly, and therefore you're less contagious. But it is worrisome that that's been true in tropical climates. Greece, on the other hand, for example, is a warmer climate where it really hasn't been spreading as much as its northern neighbors. So. Again, this is not a human coronavirus; it's a bat coronavirus. So, and its entrance into the human population for the first time. So we don't really know how it's going to act. We'll find out. I think we have to assume that it would come back next year or the year after, and we should pursue a vaccine anyway, as we were doing with SARS. I mean, people were like Peter Hotez was pursuing a vaccine for SARS. Then it didn't come back, and so that project had to drop. But we'll see. I think we'll certainly prepare.
Okay. What are I think a moment ago I had mentioned the smallpox vaccine coming back, or smallpox coming back. What I meant was the Spanish flu that had come back. But you were on, I remember reading in one of your books that when there was a recommendation, or you recommended against taking the smallpox vaccine after it had been completely eliminated for your hospital staff. What was the reasoning behind that?
Well, I recommended giving that vaccine, period. I recommended waiting for a few reasons. So This was right before our invasion in Iraq. There was a real interest in the George W. Bush administration to give smallpox vaccine. The concern was we hadn't been giving smallpox vaccine to children in this country since 1972. This was the early 2000s, so there were generations of children who were susceptible to smallpox. There was a concern that were we to invade Iraq, that there would be rogue nations or groups that would then take weaponize smallpox, aerosolize it, and spray it over this country. And so we wanted to make sure that we had first-line responders in that situation who were then immune to smallpox, and so to give them the smallpox vaccine. I thought that was a bad idea for a number of reasons. So I was a voting member of the Advisory Committee for Immunization Practices, and actually ended up being the only person who voted against that, which ended up causing me to be on 60 Minutes with Dan Rather, which was not a lot of fun, by the way, but in any case, you don't sort of like to be alone in these things. But I thought this for a few reasons. One is that there hadn't been a case of smallpox on the face of the earth since the 1970s. Number two is that even if that were true, even if people did challenge us with smallpox in a sort of weaponized way, you have time. That's a vaccine actually that can work post-exposure. If you can give that vaccine within 48 hours of exposure, you're good. Third, it's not a virus unlike this one that's where you're asymptomatic. I mean, people who have smallpox have symptoms, and they have blisters not only on their body, they have blisters on their face, so you can see that. And it's actually not spread. The fourth thing is it's not spread by a small droplet. It's spread by large droplet, which are generated from aerosolizing the blisters that are in someone's mouth. So you actually have to be fairly close to them. All those things made me think, why don't we wait? Why don't we wait until there's just one case somewhere on the face of this earth before we launch this project? Because the smallpox vaccine, when we were talking about this in the early 2000s, was made with all the technology that was available in 1796 when it was first invented, which is to say, you take a calf, you shave it, you take a rake, like an excoriating device, you shave it along the side, and then you add what is essentially an animal smallpox, probably mostly horsepox, but horsepox and cowpox, and then you put that on these bloody lines. You wait a week for the blisters to form. You harvest the blisters, spin out the hair and white cells, and freeze dry it. And we knew that vaccine could cause things like myocarditis, which is inflammation of the heart muscle, or pericarditis, which is inflammation in the sac that surrounds the heart muscle. We knew that. We knew that it could cause problems, including fatal problems. And I thought, this is not a particularly safe vaccine, given that we're not seeing any disease in this world. So why don't we just wait? And we ended up giving it to 40,000 people. There were a couple people who did die, arguably because of that vaccine. And I just think we could have waited. But again, it was a sort of a panic. People were the Defense Department wanted to do it. George W. Bush wanted to do it. Dick Cheney wanted to do it. Lou Libby wanted to do it. I just got the feeling that they weren't going to listen to us, even if we all voted against it.
Wow. So those are the things that you're weighing into account when you're recommending vaccines, is how many people are going to die if they don't get the vaccine, how many people, are going to be affected if they do. Obviously some vaccines are much safer than others, but with this current vaccine, if we were to rush it, you said that it took 26 years to develop the rotavirus vaccine. How much of that 26 years was administrative work, writing grant proposals, safety testing, and how much of that can be expedited, or how much of that can we jump past when trying to rush to get a vaccine out without, skipping too many necessary hurdles?
Right. So there was much we didn't know. We know much more about coronavirus now than we knew about rotavirus when we first started in 1980. We still had to figure out which parts of the virus induced protective immunity, which parts of the virus were the so-called virulence parts, the part that made you sick, and then separate those two things out so we could give a virus that didn't make you sick, but at the same time induced a protective immune response. That took about 10 years to figure out. We didn't at the time think that we could use a purified protein approach, which is what's being used for this virus now. We didn't think that would work. So we had to figure out which protein was the key protein, or which proteins were the key proteins. So there was still much to learn about that virus, and that took 10 years. And at the end of 10 years, we thought we had strains that could be protective without causing disease. Then we went to a pharmaceutical company and spent the next 16 years proving that this vaccine was what we hoped it would be, which meant that you had to do dose ranging studies, you had to do proof of concept studies, you had to do progressively larger and larger safety and immunogenicity studies, you had to have the right vial, you had to have the right buffering agent, you had to have the right stabilizing agent, you had to figure out how to mass produce it so that you could give hundreds of millions of doses, and you had to do real-time stability studies. That took 16 years, ending in a final trial, which was a prospective, placebo-controlled, 70,000 child, 11 country, 4-year, $350 million efficacy trial to prove that the vaccine was what it was claimed to be. And that whole effort took 26 years in total.
Wow. When people talk about phase 1, phase 2, and phase 3 of, vaccine production, vaccine testing, what do those different phases mean?
What do they mean? So as you go from phase 1 to phase 2, you're talking about progressively larger safety and then immunogenicity trials. You want to make sure it's safe, you want to make sure it's immunogenic, and you want to make sure that you've tested enough people that represent the people that are in the American population. So you can have that you're then including a broad range of genetic backgrounds so that you can have a good idea that this is as safe and as effective as you can make it at that point. And even though we had done a 70,000 child trial, a 70,000 infant child study, that still doesn't prove the vaccine is safe. I mean, it proves that it's safe as far as you know. You never really know till the vaccine is out there. But, remember, there is the other side of it. I mean, in this particular case, for us, the virus caused about 75,000 children to be hospitalized every year. It caused 60 children to die in our country every year, but caused 2,000 children to die every day in the world. So there is that other side of it. Here, there's also the other side of it, which is, that we're in the midst of this massive pandemic. The one thing that Maurice Hilleman, who I consider to be the father of modern vaccines, said that it's always true. He said, quote, "I never breathe a sigh of relief until the first 3 million doses are out there." And you're never going to do that pre-licensure. So there are some things that you may learn post-licensure. And some people will say, wait till the vaccine is out there. Wait till let them test it for another 30 years before I'm going to take it. But there is that other side. This is the HPV vaccine, is that to me. The human papillomavirus vaccine, people will say, well, it was really only tested for 7 years pre-licensure, and it's only been tested in 30,000 people. So let me wait. But the other side of it is that every year 29,000 people in the United States get cancer from HPV. 5,000 die of cancer from HPV. Your child could be one of those children. So that's the other side of it that you always have to consider, and that's true here. I do think that the approach that they use, which is this protein-directed approach against that surface glycoprotein, will work. There's every reason to believe it'll work. And there's really every reason to believe that it probably is not going to cause a safety problem. You just want to make sure that's true, especially because who are you giving it to? I mean, you're largely going to be giving it to people probably less than 45 who are otherwise healthy, and those people aren't the people typically that die of this virus. So you want to make sure that it's safe.
Okay. So with that said, if this is rushed out in a year and a half, a lot of the reasoning behind, or at least what I'm getting from this, is a lot of the reasoning behind why it's able to go through much faster is because there have been massive medical breakthroughs. Even just the ability to sequence the genome of this thing would not have been possible at this rate 20, 30 years ago. And now we know so much more. This is kind of the power of modern medicine, the power of scientific research and development. Do you think that this is going to spur, this new pandemic is going to spur an interest in medicine, an interest in, how cures and pandemics, obviously it's spurring an interest in pandemics and stuff because people are searching like crazy trying to make sure that they don't catch this thing and how to avoid it. But do you think that we're going to see a bump, sort of like during the space race, we were, fighting against the Soviets, and so we invested massively and heavily in technology to get to the moon, and now we're investing heavily in, virus research and stuff. Do you see potentially massive medical breakthroughs and a new understanding of medicine coming from this, or potentially having a kind of viral panacea? Is that a possibility, or?
Yeah, so it could play out this way. It could play out that the virus does persist, that it doesn't go away come summer months, that it continues to cause people to suffer and be hospitalized and die, not only in this country, but throughout the world. And that during that time, we are racing to develop a vaccine, which I do think will work and I do think will be safe. And then, like the movie Contagion, the hero of the story becomes the vaccine. that we make the vaccine, that in collaboration also with other pharmaceutical companies in other parts of the world, that we all make the vaccine. Probably the biggest vaccine maker in the world is actually the Serum Institute of India. That we all make the vaccine gets out there, we induce widespread population herd immunity, and it stops the virus dead in its tracks. And here, the hero of the story is vaccines. And I think if that happens, then I think most people will have a much better attitude about vaccines and what they can do.
Oh, absolutely. You look at places like I've seen footage of people in like rural India who will go on these, multi-day treks, hours and hours across miles and miles to get their child a polio vaccine because they see the effects that this is having on people around them. Whereas in the States, we kind of have the luxury of, we eradicated smallpox, polio is almost entirely wiped out. Measles, was eliminated from the US and then came back because of anti-vaxxers. And so people, they get comfortable and complacent. They're like, oh, we don't need that. But I think that you're right, that people will start to realize the importance and the efficacy of these vaccines for sure. I think that's...
I'll give you another example, just an American example. When there was an outbreak of meningitis caused by the bacteria meningococcus at Drexel University, which is a university in Philadelphia. And there were a handful of children of young adults between 18 and 22 who were college students that were getting this virus. Some of whom were dying that were getting this bacteria, meningococcus, some of whom were dying from that bacteria. Well, there wasn't a vaccine against meningococcus B that was licensed in this country at that time, but it was licensed in Canada. It would soon be licensed in the United States, but it wasn't licensed here yet. And there were parents of children in that school whose children hadn't gotten that infection yet that drove up to Canada to get that vaccine and bring it back. So fear does motivate. And I think that we're now in this sort of break the glass moment for this particular virus infection, and we'll see how this plays out. But I put a lot of faith in people like Dr. Fauci. He is a smart guy who's been doing this for a long time, and he understands, I think, the way that what the problems are. I do think when he said 12 to 18 months, I think that was amazingly optimistic, given I just think to fill this product, assuming it is a product, will take a year in itself, but we'll see.
No, you sit on the FDA's Vaccine Advisory Committee, correct?
Right.
What would it take to get a vaccine past your committee? Compelling
data. So as long as we can see data in large numbers of people that show that the vaccine is safe and is effective, and that they have, if you have, let me put it this way, if you have an immunological correlate, well, in other words, if you know that you have a certain antibody response in your bloodstream that you're going to be protected, great. And that was true with meningococcus. I mean, meningococcus only causes a few hundred cases a year in this country, so you're not going to do an efficacy trial. You can't possibly do an efficacy trial big enough that's realistic to capture those 300 people, on the both sides. But they had an immunological correlate. If you don't have an immunological correlate, i.e., we've induced this antibody response, so we know that this person is going to be protected, which we knew with meningococcus, then you have to do an efficacy trial. So I'd like to think we would see an efficacy trial. I hope this goes through the FDA. I mean, I hope that we get to review this. I think that would be fair to the public. I do.
What about alternative medicines? I know that during this time, there's a lot of people who have been bilking the public with various kinds of snake oil. You've got Jim Baker. He was promoting his colloidal silver. Jim Humble was promoting bleach. Just rapid fire real quick. Do any of these cure or prevent coronavirus? Colloidal silver? Rapid fire? Bleach?
Well, let me just say, I think where the silver thing comes from is that there was a product called Argerol, which was made by Barnes, actually, of like the Barnes Museum. He was a great collector of art, but as a treatment for syphilis, way back before we had antibiotics directed against syphilis. And that did actually, sometimes heavy metals can work for things like arsenicals, so-called, can work for bacterial infections. I guess that's where that comes from, because do I think that works for a virus? No. I think what bleach is good for sort of disinfecting surfaces, but it's not really good for disinfecting your body. No.
So you shouldn't drink a gallon of it.
Yes, I want to go on record as saying you shouldn't drink a gallon of bleach.
Are you familiar with Jilly Juice?
No, I haven't heard of that one.
So there's this woman selling this cocktail that's supposed to allegedly cure everything from cancer to homosexuality. And she's branded it as Jilly Juice. And now that the coronavirus is out there, it's being put forth as a potential cure-all for this pandemic. As well as I think Alex Jones was talking about magic toothpaste of some sort, if I'm not mistaken. What about people who say that the virus can't live at a certain high temperature and they'll stick a hairdryer in their face?
Well, you know, I'll take the hairdryer one because it's although this may surprise you, it's a little less crazy than the others. There was a study done out of Yale where they looked at the cells that line your nose. Specifically, they were doing this in a mouse model, but what they did was they infected the cells with a rhinovirus. A rhinovirus is a common cold virus, like coronavirus, like human coronavirus. And then what they did was they put those cells at different temperatures. What they found was that the warmer the temperature, because your nose is about 2 degrees cooler than your core body temperature, that as you warmed up the nose, that you actually caused those cells to excrete a substance called interferon, which had antiviral activity. So it actually did help. And so this is where the chicken soup thing comes in, that when your mother recommends chicken soup when you're younger, that as you inhale that steam, that does increase the temperature of your nose, which may cause interferon to be released, which may decrease viral replication. That makes sense. I probably wouldn't use the hair blower just because I don't think you should blow things into any orifice, including your nose. But I do think that at least has some physiological basis.
Well, can't it dry out your face and cause burns and stuff? And
right.
And it's
that's why it's not a good idea.
And a hair dryer's like that won't treat the viral infection in your lungs and stuff at all, will it? Like it won't have any effect on it.
You'd really have to blow pretty hard to get it down into your lungs. You know, I would just say this. It's think about it. Okay, you are now in possession of this miraculous drug. I mean, what do you want to do? What would you want to do? Test it. This is great. I am sure this is going to work. I know it's going to work, the colloidal silver, whatever. Let's give it to, I want to be part of a clinical trial. I want to hear, let me give it to people who have COVID or not give it to people who have COVID and see whether it works. And I'm going to patent it. I'm going to make $1 billion. But they can't do that because they know that it doesn't work and or it wouldn't work. And so I just think if something works, medicine will adopt. There's no such thing as alternative medicine. If an alternative medicine works, it's medicine. If it doesn't work, it's not an alternative.
What about weed?
Weed, marijuana? You mean?
Yeah.
Yeah.
Is weed going to cure the coronavirus?
I'm not sure. It may make you feel a little better while you're sick, but I'm not sure it's going to be a cure.
Now, a lot of people are talking about the measures to stop this virus. And as we're waiting for, a cure or a treatment, as we're waiting for a vaccine and for these tests to be rolled out, what are the steps? Obviously, some people or some places are saying, shelter in place, don't leave the house, basic sanitation, wash your hands, sneeze into your elbow. We're hearing all over the place about flattening the curve so that the healthcare system isn't overrun. But how can increasing the number of people who are being tested for the virus, how can that also help to flatten the curve and decrease the spread?
I think, well, it tells you where the infection is. I mean, I think when South Korea had tested, 200,000 people, by the time we tested 500, they knew where the infection was. They knew what provinces it was. They knew where to sort of focus their attempts to isolate. We didn't do that. I think right now, basically, we are at the level of consider everybody to be infected and just stay home. And China, what I think the good news about all this is I think this epidemic can be stopped. I mean, China did it, South Korea did it, Singapore did it without ever closing schools, Japan did it, and I am sure that there are still hundreds of or tens of millions of people in those areas that are still susceptible to this virus, yet the virus is not killing people anymore. So good. Shelter in place works. We just were really slow to do it. We're still slow to do it. I mean, there's still like 24 states that haven't sheltered in place or lockdown or whatever you want to call it. I don't know why. I mean, has this virus not gotten people's attention? This is a problem that can be solved by doing that, and we've just been very slow to do it.
I might sound slightly conspiratorial here, but I'm not sure if you can speak in an official capacity on it. But do you believe the stats and the numbers coming out of China right now?
So Bruce Aylward, from the Public Health Service here, has gone over there and has been monitoring that. I mean, unless they're all lying to him, I mean, he's published things in Nature and Science explaining what was going on over there. Unless they're all lying to him, I guess I don't believe the the denominator. I don't believe the cases number of 90,000 or so, but I think the deaths number is probably right. I mean, even if it's off by a factor of 10, even if it's not 3,300 deaths, but 30,000 deaths, that's still not bad for a population of 1.4 billion. I mean, we're doing much worse than that. I mean, if you assume their 3,000 death number is right, then we, who are a population,
300 million or so.
330 million. I mean, 330 million. So we're 3 times smaller than them. It should account for 1,000 deaths for us, but we're not. It's not. We're already over 5,000. So I don't know. I mean, the part I don't get also, here's what I would say. I really like Angela Merkel in this. I think she actually makes the most sense. What she says is, give me a doubling time of 10 days. Because with that, I think that I'm going to find that my hospital discharges are greater than my hospital admissions, that I finally flatten the curve, that I now can let people go back to work. And even though they're still going to get cases and they're still going to have deaths, at least I know that I flattened the curve. Because right now, I think on March the 26th, we had 1,000 deaths. On March the 28th, we had 2,000 deaths. So that was a doubling of 2 days. That's not good. Now we got to 4,000 deaths 4 days later. So we went from 2 days to 4 days. That's good, at least moving in the right direction, although still exponential. And so now we're at around 5,100 deaths, something like that. We had about 4,500 deaths yesterday. When do we get to 9,000 deaths? Hopefully it's more than 4 days from April 1st. If that's true, then we're starting to expand the number of days, hopefully getting to Angela Merkel's 10-day doubling period. I'd love to hear the federal government say things like, our federal government as compared to Germany's federal government saying things like that, to give us rules instead of just declaring days. April 12th, April 30th, the governor of Virginia says June the 10th. I mean, what are the rules here? What are we looking at? Don't just declare a day.
Now, if let's say that we do put all of these measures in place for 2 weeks and everyone actually follows them, or follows them for the most part, do you think that in that time period and, by Easter or something that we can actually roll back, or is that completely unrealistic?
No, I think if we really do shelter in place, really do shut down, period, because the governor of Florida just yesterday, DeSantis, just yesterday said, okay, I think we should have a statewide shutdown. I don't know what took him so long to do this. There were beaches that were still open in northern Florida. I mean, what you're looking at now in the United States is what we were doing 3 weeks ago. That's exactly right. You have an incubation period of 5 to 10 days, meaning from the time you're exposed to when you get symptoms, then you get sick and sicker and sicker and sicker. Then maybe you go to the hospital, then maybe you go to the ICU, then maybe you die. That takes about 3 weeks. So what we're looking at now is what we were doing 3 weeks ago. So your question's a good one. How about now, if we just shut it all down, really shut it all down, can we expect that 3 weeks from now, we will start to see that we're flattening the curve and starting to come down? Yes, but we have to do that. And I think we've been inconsistent in doing it.
But if come Easter, or maybe a couple weeks later, if we open everything back up and open, bars and restaurants and stuff and people start gathering, won't it just pop right back up? Or, obviously more people are going to there's going to be a little bit higher herd immunity levels, but.
Yeah, so that's the question. And so you have two things working for you as you move along. One is that there is some population immunity, and I do think that when we hear that there are a couple 100,000 cases, I think you can assume it's much more than that because we don't know. We test in a haphazard and sporadic manner, so we don't know. So you have that working for you, some level of population immunity, and there may be a climate effect that as we move into the late spring, summer, that we will see a decrease there too. We'll see. We don't know, but I think though that there will be a pop back up. The question is how big, and also what we need to talk about is the other part of this public health nightmare, which is that last week we had 3.3 million people filing for unemployment insurance. This week we have 6.6 million people filing for unemployment insurance. The current estimates are that we will have a 20% hit on our workforce, i.e. 35 million people will be out of work. That is a major financial disaster. And with that comes joblessness. With joblessness comes homelessness. And with homelessness, especially among the poor, comes all the public health tragedies that are associated with homelessness, like food insecurity and depression and suicide and domestic violence and child abuse. That will happen. That is also a public health issue. And I think that also has to be considered. So when we bring people back into the workforce. Might there be a bump? Yes. Might there be somewhat more deaths? Yes. The question is, can the healthcare system handle it? And if it can handle it, then we've done a good thing, because we do have that other part of things that we need to concern ourselves with. I mean, I'll give you one more example. If you look over the last 3 weeks, look at total number of American deaths, a total, I'm not just talking about COVID or influenza, total deaths have gone from 55,000 a week to 45,000 a week. We have 10,000 fewer deaths a week in this country. Why? Because we're not driving, because we're not killing people with guns. So we can do that. We can save lives by keeping people home. I just think that when we do that, though, there's an enormous price to pay, and there's no perfect balance. I mean, there's going to be harm either way, but there is harm either way. And you know, if we have this attitude of if there's going to be up, then we should just stay inside for the next 2 years, which is obviously not possible.
Well, yeah, for sure. So if we're looking at factors that, you know, might give us a little bit of hope, you said that you think that way more people have the virus than the actual numbers, because we haven't been able to put out all of the tests and stuff to, you know, at a wide level. What percentage do you think of this virus are asymptomatic? Do you think that because I was reading one study, I think you had shared it, or someone else had shared it, that was saying that potentially as many as 8 times for every like 9 people that we know have it that show any kind of symptoms, there could be as many as like 8 who are asymptomatic, which would mean that the virus is 8 or 9 times less deadly, but it also is 8 or 9 times as more widespread in the general public than we realize.
And China actually had said that early on. They had said that 80% of their cases were either asymptomatic or mildly symptomatic. That was something they had put out there early. I think the test that's going to tell you that is the serological testing. I mean, when we finally do antibody testing. No, not the PCR. So that's the PCR the PCR is problematic for a couple of reasons. Okay. So the PCR is just stands for polymerase chain reaction, and that just tests for small fragments of the viral genome. If you do studies, and this study was done in China and published in Research Letters, then this is on critically ill patients who were ventilated, that if they did the so-called bronchoalveolar lavage, in other words, if they took a tube, put it down into the windpipe, and then did a brushing of that lower part of the windpipe, 90+% of people who had COVID-19 were positive by PCR. But only about 60% on nasopharyngeal washes on those same patients were positive. So you have a fairly high false negative rate for that particular test. The better test, which is a perfect test, is seroepidemiological studies. In other words, look at the serum, see whether the person has antibody responses. If they're going to have an antibody response if they have the asymptomatic, mildly symptomatic, very symptomatic, and that'll tell you everything you need to know. And that's what happened in 2009, 2010 with the swine flu pandemic, which killed 12,000 people in this country. When that virus came into this country, people said that the mortality rate was 4%. After they did seroepidemiological studies to see who really was infected with that virus, the mortality rate was actually less than 0.01%. And I think that we're going to find that the mortality rate here is also much, much lower than was originally stated by the World Health Organization, which was like 3.5%. I don't think that's right.
Even still, with the numbers that we're seeing, it's still an alarming death rate. And obviously,
well, I don't know. I mean, any death rate is alarming, but I do think that when we say a couple 100,000 cases, I think we could be off by a factor of 10. I really don't, because we're testing in such a haphazard and sporadic manner. We don't know who's infected in this country. I think when we do the serum studies, which we'll do, I know the government is interested in doing those studies, then we'll know. And we'll see.
But even if we're off by a factor of 10, if, you know, instead of 200,000 people, if 2 million people, or let's say 3 million people have it right now, then, you know, you're looking at 100 times as many people as have died right now that will die from this virus. So, you know, that's...
Well, remember, but a lot of the people who are infected are asymptomatically infected. A lot of the people who are infected are children who aren't dying from this virus. I mean, remarkably so, actually. I mean, for the roughly 50,000 deaths we've had in this world, it's the rare child who was killed by this virus. I mean, someone less than 18 years of age. So that they may be a real sort of a base of that iceberg that you don't know about yet. So I think that when it's all said and done, I think the mortality rate of this may well be less than 0.1%. We'll see.
That's still not. I'm still thinking if it's still, you know, 500 times as many people that wind up getting it, or 100 times more people get it, you know, 100 times 5,000 deaths is still 500,000 people, unless my math is completely off.
No, you're right, but it assumes everybody gets it. or it assumes everybody who's susceptible gets it, or it even assumes most people who are susceptible to get it. I don't think that's what's happened in China or South Korea. I think most people are still susceptible to this virus but haven't gotten it because they seem to have been able to stop spread. And I do think it's not just respiratory spread. I think there is a so-called fecal-oral component to this. I mean, it does act a little bit like norovirus, right? I mean, cruise ships, nursing homes. And so people talk endlessly correctly about washing hands, cleaning surfaces. That's more like fecal-oral spread. That's more like norovirus in terms of how it spreads.
When you say fecal-oral spread, you mean through like fecal matter and stuff with...
Yeah, but it ends up on hands. It ends up on surfaces. I mean, remember the norovirus, the so-called poop cruise that was a couple of years ago? I bet if you went onto that cruise ship and just sort of took samples of the surfaces, dressers and desks and just the handrails and stuff, that you would have found that virus was everywhere.
So we're basically living in poop and we don't even realize it.
We had a norovirus outbreak on one of our floors in the hospitals. One child came in with norovirus, and then like a number of children on the floor got sick. A number of the staff got sick. I mean, it's you don't have to, it's not. It's just it starts to live on surfaces, and certainly we know the virus can live for a couple of days on surfaces.
Yeah, there was a piece in Pediatrics recently that said that kids were shedding the virus via the fecal oral route.
That's right, including live virus. I mean, it wasn't just by PCR, which is just test for genome. Children can shed live infectious virus, which is really, that's the test you really want, that you're never going to get, because that's just a research tool. But when somebody's PCR positive, that doesn't necessarily mean they're contagious. It just means that at some point recently they were infected with the virus. I mean, you really want to know who's shedding infectious virus.
Okay, now there's a lot more misinformation that's out there right now related to things like ibuprofen. What's up with that? What are the things that are being put forth, and is there any legitimacy to it?
In short, no. This came out from a hypothesis by a group in Vienna, Austria, who wondered whether or not ibuprofen could in any way affect the expression of the receptor, the binding receptor on cells for coronavirus. In other words, the binding receptor is so-called angiotensin converting enzyme. Could ibuprofen affect that? They just sort of mused about that. There were no data to suggest that. Then the French Minister of Health got up and said, don't take ibuprofen, take acetaminophen instead, Tylenol instead. I mean, based on this unproven, no data supporting hypothesis. And here's what I would say. First of all, fever is part of your immune system. It's an adaptive part of your immune response. It's actually the first chapter of the next book, Overkill, when modern medicine goes too far. I mean, everything that walks, flies, crawls, or swims on this planet can make fever. Why? Because it's adaptive. And the reason is every aspect of your immune system works better at a higher temperature, but you pay a metabolic price for that. You pay an energy price for that, roughly an increase of 12% in your basal metabolic rate for every degree centigrade. So you only do it when you need it. And your immune system will initially make proteins that travel to your hypothalamus that reset your body temperature to a higher level so you feel cold. So now you want to feel warmer. You put on warmer clothing, you put a log on the fire, you shiver, you shunt blood from your arms and legs to your core. You want to be hotter because your immune system works better at a higher temperature. And everybody thinks when they treat fever that they're better, that therefore they're better, but they're not, because study after study has shown that when you treat fever, you prolong and worsen illness. Study after study has shown that in people, study after study showed that in experimental animals, but we are never going to get past this. I think it is so ingrained in our culture to treat fever that I don't think everybody's going to read my book and think, that makes sense. I'm not going to treat fever anymore, but maybe I'll convince a few people.
Well, if you have a horrible fever and you're suffering, you just want the pain and stuff to be alleviated.
But what you're doing is you are at some level crippling your immune system. Why don't you let your immune system work for you? Your overall, your disease will last less long. We had a child in our hospital. I'll give you an example who was a boy who was a soccer player. He got struck by a soccer ball in his hip. He developed something called aseptic thrombophlebitis, which just means a bacterial infection in a clot in his vein. That bacterial infection then spread to his lungs, causing abscesses, spread to his brain, causing abscesses, spread to his bones and joints, causing abscesses. He was sick. And every 2 hours, he was treated with either ibuprofen, a non-steroidal anti-inflammatory, or Tylenol. Every 2 hours to try and keep his raging fever down. And every day, even though he was treated with the right antibiotic, his blood culture was positive for that bacteria, day after day after day, until finally I thought, let's at least give his immune system a chance to work. I mean, it's trying to work. Don't keep his fever down, because his white blood cells will kill bacteria better at a higher temperature. So I sat down with the parents, who were great, and explained this to him. I sat down with a boy who was a brave adolescent boy and explained to him, and I sat down with the nurses and said, don't treat his fever. If he's willing to take the fever, don't treat his fever. And like in a day or a day and a half, his blood culture cleared. Now, maybe that was coincidence. Maybe it was going to clear anyway, but you couldn't convince the parents of that. They thought this was a miracle.
Now I know that, alternative medicine people and people saying, modern medicine just treats the symptoms and not the disease and stuff, they're going to come out of the woodwork and they're going to be like, see, you shouldn't take medicine, let the body do its own work. Obviously, you're speaking to a very specific case to, treating fevers. You're not saying avoid, all prescriptions and all medication, because you wouldn't be a doctor if you didn't believe in.
That's right. Like I believe in antibiotics for bacterial infections, which also is not a belief system. It's an evidence-based system.
Yes.
I believe in antivirals for certain virus infections. I think where there are data clearly showing that something worked, that you should do it. But don't make it up.
Is the coronavirus caused by 5G?
By what?
By 5G networks, like the new cell phone towers.
Oh, I see. No, it's caused by a bat coronavirus that somehow combined with a pangolin. So there are basically, it's 96% bat coronavirus, and then it has a small percentage of pangolin coronavirus that then allowed it to more easily attach to human cells. It's just one of those genetic reassortant events that occur in nature occasionally.
I saw a recent study saying that, when studying this coronavirus, that it's demonstrably been shown that it was not man-made. Can you speak to that at all, as far as these claims that it is this weaponized virus that was made in the laboratory and is?
Yeah, I think we certainly know the sequence. We know how it could have been created, and we do know that China has a taste for bats, if you will. I mean, they eat fried bats, they drink bat soup, they drink bat tea. So it's that this could have then emerged into the human population in this open market. Is not surprising. That's where often it does happen. It's where SARS happened. MERS came out of Saudi Arabia, but and that's more camel coronavirus.
Yeah. So H1N1, like viruses making that jump from animals to humans is actually very common. With the H1N1 we had from pigs, MERS was from camels. Now we've got bats, but it's just that interaction between humans and animals, especially in unhygienic settings, where they can mutate and jump. Now, I wanted to ask you, we don't have a whole lot more time, and I want to be conscious of that, because I told you I'd take an hour and a half here live. But there's a vaccine injury compensation program, and you've talked about that in your books, and oftentimes people will put this forward, anti-vaxxers will put this forward as evidence for, the government knows that they're harmful and they have this entire injury compensation program. And I didn't realize the details until I started reading your book, that a lot of the cases that are put forth, this is basically a program to there's a very small percentage of cases with certain vaccines that can cause harm. We know that it can cause harm, but the alternative is much, much worse. And so we've set up a fund to basically say, if you've been harmed by this, you can, be compensated. But how has that system been abused?
Well, so it was put in place. The National Childhood Vaccine Injury Act was passed in 1986. It went into effect in 1988. It includes this vaccine injury compensation program. And the goal is to try and put at least somewhat of a firewall between the someone who believes that a vaccine has hurt them and the pharmaceutical industry, so that there's not a lot of time spent in civil court in front of juries where a lot of bad decisions can be made that are emotional and not science-based. So it has a very low bar the vaccine injury compensation program, which is why you don't see people really going to civil court suing pharmaceutical companies. Because frankly, if you can't win in vaccine court, you're not going to be able to win because the bar is so low. I mean, there often are people. You see people compensated for harms caused by a vaccine that weren't caused by the vaccine, for which there's abundant evidence that it wasn't caused by the vaccine. But this is a pop-off valve. It's as you mandate many vaccines for children in this population, you want to make sure that you have some sort of pop-off valve. I mean, what happened in the early 1980s was associated with this false notion that the whole cell or the older version of the pertussis or whooping cough vaccine could cause permanent brain damage. We lost vaccine manufacturing in this country. I mean, company after country stopped making. We had one pertussis vaccine maker that was about to just say, forget it. And so something had to be put in that way. People think wrongly, by the way, that just because something is compensated in that program, that it really is causal. I mean, that's just not true. I mean, if you try to look to the courts are a place to settle disputes. The courts aren't a place to determine scientific truths. Scientific studies are the place to determine scientific truths. So that's not where you look. The example I think I used in one of my books was a child or a woman who was a psychic, and worked for the police department, which was the most upsetting part of actually the whole story. But she had a headache. She goes to a neurologist at Temple. The neurologist gets a CT scan, following which she says she lost her psychic powers. So she sued the doctor. She sued Temple and won. Like a couple $1 million. It was settled. It was appealed where the verdict was lessened, but she still won. I mean, come on. So therefore, what we learned from the court is psychics can lose their psychic power in a CT scan. And more importantly, that a neurologist should have known better than to get a CT scan on a psychic.
Wow. Yeah. I had no idea about that psychic story. I remember you talking about you could show that peanut butter caused you to get autism or something. If you the logic and the reasoning that you showed, it wasn't that there was actually a causal connection between peanut butter and autism, but it was like by the reasoning that they were using in winning these cases, you could apply that same reasoning in this kind of reductio ad absurdum type of scenario to peanut butter or to anything and show that it causes autism or illnesses, or to have you lose your psychic powers. Apparently that's insane. So,
see, well, I would argue that the defense should have argued that she should have seen it coming, but I'm not sure they did that. She was a psychic. Shouldn't she have known that?
I have a whole series on my channel called Exposing Psychics, where I walk through the methods that they use, how they've been tested and proven wrong, and it's had a pretty good effect. And it feels good to push back against a lot of these hucksters and charlatans, because they really are vultures, and they're bilking the most desperate, vulnerable people out of their life savings when they're most vulnerable and bereaved. But back onto the coronavirus note, where do we go from here moving forward? As just the general public, and obviously listen to the guidelines of the CDC and the FDA and the NIH and stuff. If they're saying stay home, don't gather in groups of 10 or more, obviously listen to those. But what can people do going forward to help to curb the spread of this, to help out in any way that they can? What are some steps and some guidelines that you would personally offer to people?
So I think for now we are locked in. We are sheltered in place. I think what will happen, hopefully, is that you'll start to see much more in the way of serum studies being done, seeing who's immune and who's not. I think once we know that, then we can be more surgical, so to speak, about who is on the front lines of taking care of these folks. Because once you're immune, you're going to be immune for a few years, so they pose a lesser risk. And similarly, I think once we identify a group of people who are immune, they can help older people who, for example, can't shop or have no one to shop for them to shop, instead of asking them to go, because that's the person who really needs to stay inside, is someone who's older and infirm. And also visit people in nursing homes. The thing, I got a call from a friend of mine who's in her mid-80s, who was a pediatric neuropathologist and one of the best ever. So she's in an assisted living facility in New Jersey, and she's in her mid-80s. She said now they can't meet together to eat, so she just has her breakfast, lunch, and dinner sort of served to her through her door. She can have no visitors. She said, do you know how awful that is for someone in their mid-80s to be isolated like that? I feel like I'm in prison. And you know, so those are the people that could visit nursing homes. So I think that we could create an army of people who we know are immune, who can go out there and do the things we need to do now, because all of us are asked to stay inside now otherwise.
That's a fantastic point. You'll see this kind of emerging workforce of people who have built up an immunity. Also, I think there are programs, I can't think off the top of my head the names of them, but there are programs where you can actually call and talk to elderly people right now, just from your home, you know, to keep them company and you know, see how they're doing and check in on them. And so if there's a program like that in your state, or even just call up a local nursing home and say like, hey, is there anyone who's lonely? You can forward me through to their local landline or something. I think that could definitely be a positive way to reach out and help people. The one thing that I have a video right now. It's unlisted on my Patreon page for early access viewers and stuff, but I'm going to release it here in the next day or two, talking about the effects of coronavirus versus religion and these religious gatherings that have completely ignored any kind of guidelines and have said, we're not going to give up our ability to meet because we are a spiritual hospital for the soul sick. And so this is an essential service. But in many cases, you have people kissing the same icons without disinfecting them, gathering in large crowds, singing, which is, you know, you're belting out and projecting your voice. What would you say to people who see it as, you know, God versus medicine? This, you know, I have to either follow my faith or follow, you know, the guidelines of these medical organizations. What would you say to someone like that in this dire time of a pandemic?
I mean, God gave us a brain, I mean, to think and reason. So what is most upsetting about this is I think I think Trump's draw to evangelists is not just that sort of single issue of abortion. I do think he's a science denier, as are they. You simply declare your own truth, whatever truth is you find most convenient. And it's irresponsible not only to those who are in that community, but to those who come in contact with that community. To deny science is just wrong. I mean, I'm not a particularly religious person at all, but I do. There are a number of people I know who are deeply religious, and I have an enormous amount of respect for them. But one of the parts that I respect is they don't feel that they have to literally interpret the Bible. I mean, they understand that evolution is real, that creationism isn't, and so you can have both of those things. So I don't think you have to buy the whole one side of the menu. You can think for yourself.
Yeah, critical thinking is key, but also going where the evidence leads. You know, we've done these tests, we have this information, and we should follow it. We should figure out what's true, what's not, use critical thinking, use logic, reason, and science, and then follow it and stick to it. So is there anything else before I let you go that you would like to touch on that you feel like we've missed, or anything in particular that you would like to plug or talk about, you know, any projects you're working on?
Yeah, I think we're going to get past this. I do. I think we finally are now locked in enough of this country that you're going to start to see, at least in a few weeks, things turn around a little bit, because it's just so grim right now. I mean, when you hear the government say 240,000 deaths, or you hear the governor of Virginia say, you know, June 10th, it's just so demoralizing. I do think that there will be. I actually was fortunate enough to be able to talk to Ambassador Birx on the phone yesterday, Deborah Birx, and the administration has a number of people in it who really are trying to figure out the best way to get us back to work. You just don't hear that much, unfortunately. But I think people should take heart in that. I do think that there is a lot of talented people that are at least giving advice. Hopefully, it's going to be listened to, and I do think things will be. I think we're going to get past this. I do.
Well, that's good to hear. Hopefully we can get past it, and we can, you know, if everyone actually shelters in place and follows the guidelines, I think we'll get past it a lot faster. But it's hopeful to hear that there are people working on vaccines and treatments and cures that the world is coming together in a way that we've never really seen, at least not in my lifetime. And it's encouraging. There's a lot of frustration. There's a lot of hopelessness. There's a lot of depression, but there's also a lot of reason to hope. And there are a lot of reasons to see that, you know, we can overcome this. We will overcome this. And hopefully we'll come out on the other side just a little bit stronger. Do you want to talk briefly about your new book that you just released?
Sure. So I have a book coming out with HarperCollins on April 14th. It's called Overkill: When Modern Medicine Goes Too Far. It goes through, I think, about 15 or so situations in which there's abundant scientific evidence that we shouldn't be doing something, but we do it anyway. So, for example, finishing the antibiotic course. There now is abundant evidence that once you feel better for a couple days, and I go through a number of 10 or so infections, you really can stop. So that's one of many examples. And again, it's all data-based. It's not, you don't have to believe me. I try and go through the science in a compelling and clear manner so you can see where things are. And in fact, that example, there was recently a paper in Lancet that said, is this the end of the antibiotic course? I think, it's the only disease for which we set something at a determined length of illness, length of treatment at the beginning, right? You treat asthma until you're not wheezing anymore. You treat pain till you're pain-free. Here, somehow we say treat for 10 days, treat for 14 days, and you're taking antibiotics when you feel fine. And there's a downside to that. And I go, that's just one of many examples.
Interesting. Well, I might have to have you on to talk more about that because, I know that there are so many things I'm not a medical expert in, and yet I find absolutely fascinating. So I'm going to have to pick up your book, and maybe at another point when things aren't so crazy and hectic with all of this, we'll have a nice sit down talk and stuff.
Well, send me your address by email, and I'll make sure to send you a copy of the book.
Oh, I really appreciate that. Thank you. And by the way, I've put your books put a link to your Amazon list of books in the description below this video. So if any of you guys are interested in Dr. Offit's works, you can go and click that link and go to those to check out those books. And hopefully we'll see you again soon, and stay safe, stay healthy. To everyone right now who has been supporting my show through Patreon and through PayPal and stuff, I really appreciate it. This is a fan-funded show. You can support my work at patreon.com/holykoolaid or through a one-time donation on PayPal. And as always, to everyone watching, thank you guys for joining us. Dare to be curious, but don't drink the Kool-Aid.